quadratic equations in standard form. It's going to look very familiar to you. Quadratic equations in standard form is ax squared plus bx plus c equals 0. So quadratic equations in standard form, you get all your x's and numbers on one side and set it equal to 0. Your answers for x, your solutions, are the following. Put a little star here. They're called zeros. They are called x-intercepts. And the solution set. Are found by solving for x. Ax squared plus bx plus c equal to 0. If they ask you a question, they're going to interchange these words. They're going to say, what's the zeros? What's the x-intercepts? What's the solution set? It's all the same, y'all. It's all the same. Okay? So we're going to do this right now. We'll do an example that they could ask you. They'll say, hey, find the zeros, there's that word, of p of x equals x squared minus 6x plus 9, and graph it. So what are they really asking for? Well, they're asking for you to solve this as if it was equal to 0. Set it equal to 0. X squared minus 6x plus 9 equals 0. And how do we solve that? Well, to me, the easiest thing to do is to factor. Two numbers that multiply to 9 but make a negative 6 would be x and x would be minus 3 and minus 3. Or x minus 3 squared. That's important. That'll come into play later on. That means what's the value of x that will give you a 0 here? It would be 3. And 3 is actually a double root because there's 2 of them. That'll come into play later. Now, if you were to graph this on your graphing calculator, or obviously use Desmos, I'm going to go back to my graphing calculator just to show you something. See how right now when I type in, oh, there's a glare, I'm sorry, with my light. See how if I hit y equals, my plot 1 is highlighted. I don't want to graph a function when my plot 1 is highlighted. So I'm going to go up to it and turn it off. Hit enter. Now it's not highlighted anymore. So now going back down to y1, I'm going to type in x squared minus 6x plus 9. And my standard view is zoom 6. That's the view that'll give me like a 10 by 10 by 10. 10 up, 10 down. Oh, look at that. Look at that. There's that curve. Hey, where's the x-intercept? Where does it intersect the x-axis? 1, 2, 3. Notice it only has one x-intercept. 1, 2, 3. Notice something else. Notice that it's a double root. This is going to become important for later. And it touches the x-axis at x equals 3. This is important for something we're doing later, but I'm setting you up for good stuff ahead. But that is the graph of, if I asked you what is the 0 would be 3. That's what you would say, 3. Okay? Let's do another one. What if they said, now they're and again, it's all about changing words, but it really just means the same thing. What if they say, hey, solve 2x squared plus 4x minus 16 equals 0 and graph? 2x squared plus 4x minus 16. Okay, so not bad. My first nature is to factor. So if I factor, I see that they all have a 2, so I'm going to take out a 2. And I'm left with x squared plus 2x minus 8. And then I'm going to factor what's inside here. You can keep that 2 on the outside. X and x, two numbers that multiply to -8, but add to a 2. Multiply to -8, but add to a 2 would be a +4 and a -2. But what are my solutions? What are my answers for x? Well, the zero product property says that whatever your factors are, you just set them both equal to 0. So in this case, you have two answers. You have -4, because that would become 0, or +2. These are your zeros. Your x-intercepts would also be what the zeros are. So what does that mean? Well, let's graph it, just to show you what that looks like. So 2x squared, oh, let me clear it. 2x squared plus 4x minus 16. And hit graph. Huh. 1, 2, 3, -4. And then the other point is at 1, 2. And then that -16 is really the y-intercept, which we know about. So interesting, it has x-intercepts at -4, 0, and at 2, 0. That's an x-intercept, that's an x-intercept, that's a 0, that's a 0. These are all interchangeable words. What I want you to notice on this one is that it crosses through the x-axis at the zeros. Up here, it was touching when x was 3 and it was a double root. Here, it crossed through the x-axis at those particular zeros. Again, very neat. All right, let's just do a couple more solving examples, not necessarily graphing, quadratics. We'll do a couple solving, and then we're done. So let's do, let's see, what is this? -5, hope I wrote this right. Yes, plus 16x minus 3x squared equals 0. We're going to do a 2x squared equals -10. And then we'll do a 2 times x minus 1 squared equals 14. And then I'm going to do one more, and then we will be done on this last example. Solve by completing the square. All right, so let's go back up to this one. These last three, and we're done. All right, so first thing I noticed with this one is I don't like the way it's written. That's why, as you can see, I was kind of like, oh, is that how I wrote it? First of all, I like my x squared to be positive whenever I can. And I like it to go in a descending order. So I'm going to move all of these over to that side. I'm going to put the 0 on this side. So I'm going to have positive 3x squared, a minus 16x, and then a plus 5. And now I'm going to factor this because, again, that's my go-to. I like to factor. You could quadratic formula, but factoring is so much easier. So because there's a 3 here, I need to know what multiplies to 15, but adds to the middle of negative 16. That's how I do it. So I put an x here and an x here, two numbers that multiply to 15, but add to a negative 16. Well, wouldn't that be negative 1 and negative 15? Don't those two multiply to a positive 15, but they both add to a negative 16? Now, because this has a 3, you have to divide each of these by 3. If this was a 2, divide by 2, divide by 2. If it was a 1, divide by 1, which does nothing. Now, if it can reduce like this one, reduce it. Like this would be x minus 5, because 15 divided by 3 is 5. If it can't, this 3 goes in front of the x. So 3x minus 1. So now, what are my solutions to this? My answers: set this equal to 0 and set this one equal to 0. That's what the zero product property says. So x would be positive 5. For this one, x would be 1/3. And there's your solutions. That's your zeros. Those are also your x-intercepts. Hint, hint, hint. What about this one? 2x squared equals negative 10. Couple ways to do it. Sometimes when I see like no other x term, when it's just x squared and then equals a number, if it was just a number, I just go like this. I divide by 2. X squared equals negative 10 divided by 2 is negative 5. Oh, and this goes back to a section we did a while ago. Take the square root, because to undo a squared, you square root. And if there's a square root underneath a negative, under a square root, you pull out the I. So you would have I square root 5. And don't forget, it's plus or minus. That is the solution. However, if I were to graph this, because again, I'm trying to get you ahead of the game. If you were to put this in the graphing calculator as y equals 2x squared, and then you bring the 10 over plus 10, just to show you, 2x squared plus 10. Oh, I know I'm out of the window range, actually. Meh. Zoom out. Let's go up a little bit. There it is. Right, this graph has been shifted up 10. Up 10, so it's like this. Look at that. It's not crossing the x-axis when it has imaginaries. Not crossing the x-axis when the solutions are i's. Interesting stuff. All right, let's do this one more here. 2 times x minus 1 squared equals 14. Normally what you want to do is obviously set it equal to 0. Since these are both divisible by each other, I'm going to divide that 2 out. So I get x minus 1 squared equals 7. How do you undo a squared? Square root, cross, cross. You get x minus 1 equals plus or minus square root 7. And then you can easily add the 1 in front. I always like to put it in front of the plus or minus. So my final answer would be x equals 1 plus the square root of 7. But it would also be 1 minus the square root of 7, because there's 2 answers. That's where it would cross the x-axis too. And our last and final question for the night. Solve by completing the square. Now, we just did a whole 3 examples on the last lesson of completing the square. Let's go over it again. This time there's no y here, but it's the same thing. Okay, same exact thing. And I'm going to write little steps over again so you know. Bring the number over. Here's the number. Bring it over. Change its sign. X squared minus 4x equals -2. Now, this is a nice one because this has a 1, so we're not going to have any problems here. Just go plus blank plus blank. So write your blanks. Write your blanks. See, if there was like a 2 here or a 3 here, we'd have to factor it out, but we don't have to factor out anything. It's a 1. Now take half of the middle x value and square it. Half that middle. Half of -4 is -2. Square it would go back to being +4. Since I didn't factor anything out, that +4 goes over here also. Now, rewrite it factored. Rewrite it in a factored form. So this side would be x what squared? Whatever you took a half of, -2. That's the factored form of that. -2 plus 4 is 2. And look, that is exactly what we did up here. If you have a squared by itself, you can undo it by taking a square root on both sides. And so you would have x minus 2 equals plus or minus square root 2. And then solve for x, bring that 2 in front of the plus or minus, but you have to write it out as 2 separate solutions. X can be 2 plus the square root of 2, and x can be 2 minus the square root of 2. They're going to make you write it as 2 separate, I believe.